All right. Hope I'm audible. Yeah. Okay. Cool. Hello, everyone. Welcome to my talk. I hope you're all having good DEF CON so far. Today, I'll be talking about some of the risks in dangling issues and federated credentials. For those who don't know me, I'm Gautam. As Mike introduced me, I'm a senior security engineer at Microsoft. And by the way, I'm not into MSRC. I don't look at any of the bug bounty reports. So yeah, please don't reach out to me on that one. Like this is from my coworker. He uses this joke, so I tried using that here as well. And I'm on the Serpent team, Services Pentest, and we have quite a few folks from my team coming here supporting me as well. Thank you. And from conference standpoint, a little bit about myself. This is my first conference at DEF CON as a speaker. And before this, I also gave a workshop on SemGrep last year. And we were working with a few other coworkers to author some SemGrep rules. That was my first time experiencing DEF CON. It was a truly amazing feeling. Then I wanted to be a speaker, giving a talk and delivering a cool technique. So I'm here right now. I'm excited to be sharing this with you all. And I also spoke at OWASP Boston, like Boston Application Security Conference. And do we have anyone from Boston OWASP here? No worries, yeah. Because I have a few friends there who invited me for the Boston conference, so I thought I'll check. And you can always reach out to me on LinkedIn and Twitter. Hawkeye Dev is my alias, so feel free to tag me there. So I'd like to share a funny story before we dive into the technical details. So I was drafting the CFPs and I showed it to my coworkers, and there were some interesting talk titles that we discussed, and some of them were even mouthful, like Federated Credentials or Fed Wrangling. And even we contemplated a lot with Grand Theft Token. I was really into it. I wanted to use that, but somehow I chickened out and I didn't want to. I didn't use that. And even I wanted to use the Steal the Fed, because that goes in line with the DEF CON theme of Spot the Fed, that game that usually played to identify the feds in the conference. But I didn't want to get in trouble, so I didn't use that. So just a little funny story around that. And coming to the inspiration of my talk, like today, I was looking at, or I was into dangling reply URLs, looking into Entra ID, how they can be taken over. So there was some cool research by Dirk Jan, and I'm sure you might have heard from the previous talk speaker as well, and they've got some good work there. And even my current manager, Krishna, he also presented at some OWASP Pacific Northwest conference on common vulnerabilities in OAuth. And those were some of the talks that were related on dangling reply URLs. And then as I said earlier, I was presenting at OWASP Boston, and there I was presenting on auth bypass by controlling STS, a cool technique where an attacker is in control of the STS. And while I was researching on federated credentials, I started to look from a lens of, hey, we have dangling reply URLs, and then there's a possibility of attacker controlling the STS. So why can't we just mash them together? So I was able to connect the dots, and then I started to look at, okay, so here is how this can happen, and the neurons in my mind or in my brain got wired together, and then they fired all of a sudden, and it occurred to me. And that's how I ended up on this topic. And before we dive in, I want to do a quick call out. This is going to be a super technical talk, and it requires some fundamentals of OAuth and OpenID Connect. I'll try my best to, put in animations and keep it simple as possible. And if you don't have any OAuth background, that's still fine. Yeah, we'll try to cover up with some animations here. And another important call out here is that though this talk is mostly focused on Entra and Azure environments, but the learnings can be applied across the board. We can take these learnings to other cloud providers and other identity providers as well. So in this talk, I'll be diving about some of the federated credentials overview and taking you through some of the dangling issuers problems, and after that we'll look at how we can discover them and some mitigations and best practices. So this is going to be a super technical talk, so please buckle up, and eventually you'll have some learnings there as well. So coming to the overview of the identity and how identity has evolved, back in the day, like back in 2010, when cloud was relatively new, the identity model that was there was traditional secrets, shared secrets, API keys, and certificates. And then, as time progressed, there was OAuth and OpenID Connect that started evolving, and the community started coming up with specs around that. And there are different code grant flows and token flows that were in OAuth, and eventually the cloud providers started adopting that, and they came up with identity and access management and managed identities and IMDS that rely on RBAC for authorization and stuff. That was fun. That was good evolution. And then we all saw the rise of Kubernetes and the cloud native environments, right? And that triggered another change where we needed some sort of an identity crisis. That was again an identity crisis. Let's say if you have a Kubernetes workloads that wanted to access some cloud resources, that was again going back to square one of using shared secrets and certificates. So what were the lessons learned? If you look back and see, again, there was a need for the cloud providers to come up with some sort of a existing solution that can be adopted. So they used OIDC on top of the Kubernetes and other workloads, and they created something known as workload identity federation. And now the cloud providers started adopting that or using that. So Google was the first one to come up with implementing workload identity federation, and then AWS and Azure or Entra ID started adopting them and implementing them. So let's deep dive into some of the workload identity federation nuances. And I'll talk through a common scenario where we have a CI/CD, like here in this case, let's say Azure DevOps, and would want to deploy resources to a Kubernetes cluster, Azure Kubernetes, right? And then it doesn't happen magically. It has to have some sort of a credential material under the hood, and it uses a client credential or a secret or a certificate, and that is injected into or it's a secret that's hosted as a service connection. And in the case of Azure Kubernetes service, the Kubernetes pods that are running needs to have access to the resources. Again, there needs to have some sort of credential material there. And it's again a client secret or certificate back in the day. And we all know what are the challenges that we have with having secrets and certificates. One, there's a lot of overhead of rotation. And two, there's a risk of leaking secrets and certificates, and eventually some downtime that is required to rotate them, and that's a pain. So that's when the workload identity federation came in. It was like, hey, let's not use any client secret or certificate. Okay, let's use workload identities. So workload identity federation come into picture and made it streamlined a little, and it eliminated the secrets or the need for secrets and certificates, and used the workload identity that the workloads are using to access the resources. And some of the scenarios that are supported here are like CI/CD, the containers, and the serverless workloads that have their identity. They can now use their own identity to talk to Azure resources or any other cloud resources. And if you want to look at the workload identity federation in Entra, it enables external workloads to access Azure resources with their existing identity. And how does it happen? It happens using a concept called as Federated Credentials, which are commonly known as FICs. And they use the OpenID Connect protocol that's under the hood, that's exchanging the tokens and giving us access tokens for other resources. So we'll deep dive into some of these scenarios and how the tokens are exchanged, how are these obtaining tokens and stuff. A bit more about Federated Credentials or FICs here. So this is an excerpt that this is a screenshot that I got from the Microsoft Learn documentation. You can see here the fix are a new type of credential. It's not a client secret or certificate, it's a new type of credential that enables workload identities and gives access to Microsoft or Entra protected resources without needing to manage those secrets. And there are some nuances here, like when we are setting up FIC, there needs to have a trust relationship first with the external identity provider. So here in this case, the workload identity provider has to have a trust relationship with the Entra, and then the Entra will start trusting the tokens and that are obtained by the external identity provider. So once the Entra gets these tokens, that validates, and then it will issue tokens. So there are two main scenarios that are supported in FICs currently in Azure. So one, FICs are used in app registrations. Two, the FICs are used in user-assigned managed identities. And we'll see in these two scenarios and how they are configured and how they get tokens and stuff. So far, we went through what, through the timeline, through a common scenario, and then we also looked at the workload identity federation and how we ended up on federated identity credentials. Now let's take a bit further, let's go a bit further and see, following the same setup. Now that we know about federated identity credentials, let's say, hey, now my Azure DevOps pipeline is using a federated identity credential and is deploying to Azure Kubernetes using a service connection. And Azure Kubernetes is also accessing the pods in Azure Kubernetes service are also accessing Azure resources using a user-assigned managed identity. But how do these happen? Because of the federated credentials. So there's some configuration that's involved. So there's a trust relationship, as I said, right? Like there's a mutual trust that needs to happen. And here is a quick configuration that the developer has put in. And if we were to dig deep and see how the tokens are obtained, the workload clients typically use their identity to get a token called a federated token from their own identity provider. So here, let's say Kubernetes uses its Kubernetes OIDC to get its own federated token. And now it sends that federated token to Entra ID. The Entra ID, when it receives that request, it sees, okay, it is coming from a certain client, and then it starts to pull up its configuration and then sends a request to the configured identity provider's well-known config endpoint. So this is OIDC. So this is, by the way, OIDC, where it fetches the OpenID config metadata document. And in that metadata document, there is a field called JWKS URI, which is known as Java Web Keyset. Sorry, not Java, JSON Web Keyset. And the JWKS URI holds the public keys. Now the Entra sends a request to fetch that document, and it has the public keys. So basically, now the Entra has a signed token from the identity provider and also the public keys that are used to validate. The Entra ID will validate the signature and checks for a few other fields like issuer, audience, and a bunch of other stuff that matches or not, and returns an access token back. So in a nutshell, the workload clients use their identity to get a federated token and use that token to exchange for an access token with Entra ID. Entra ID does the validation by sending a request to OpenID config, fetches the metadata document, gets the public keys from the JWKS URI, and then uses those public keys to validate the token signature. And eventually it gets an access token. But yeah, this seems pretty interesting. And then how is that even it's requesting tokens? So there's a flow called client credential flow, and in this client credential flow, we typically use a client ID and a client assertion. In this client assertion, that's where the federated token is passed as a request. And client assertion, the client assertion is typically a JWT, JSON Web Token, and you can create your own JSON Web Token. So we'll see how that goes. But bottom line is that it uses a client credential flow to obtain tokens using the federated token. Now we already saw a setup. Now let's look at the untrusted issuer setup. So here in this case, let's say a developer has configured federated credentials, but they've added some custom domains for testing or for some other purpose, they didn't really know what was the real outcome of it's going to be and what's the risk. And they've added that as a trusted issuer on the app registration. At the same time, we have two cases here. Like one is the app registration, the other is user assigned managed identity. And the other one, the developer also added a storage account or a static website in Azure Storage. And that, if they are not, if they are not registered, they can lead to a problem called as dangling issuers problem. So let's see what happens in dangling issuers. So typically, a dangling issuer is any host that's available for takeover in a federated credential. And they can manifest in like multiple ways. Like one, we can have a custom domain that's configured. So here in this case, let's say the app trust like cloud.secure-sts.com. And if that domain is unregistered or expired, now an attacker can take over that domain, register and impersonate as an issuer. And we'll see that how and what that leads to in the upcoming slides. Similarly, if we have a cloud service subdomain that is configured as a trusted issuer in the app registration or the user assigned managed entity in federated credentials, and let's assume that the app service developer has configured that, and after a while they deleted that resource, and now it's available and anybody can claim that one. Now if an attacker claims it, they can hijack that resource and eventually take over and impersonate as the issuer. So at a high level, so dangling issuers is a problem that an attacker can take over the domains and then impersonate the issuer, and then we'll see how that translates to. So here's a quick setup that I have, and I'm going to show you some of the slides on how these issuers are going to be used. So the first case is going to be on the dangling issuers in app registrations. Let's look at that case. In the app registration fix setup, so here is the case where you have a federated credential, and we have a developer that configured as cloud.secure-sts.com. And let's assume that that domain is available for registration because it's a custom domain. Anything can happen, like developers change, they move to different teams, they move different companies, somebody forget to register it again, so anybody can take over that domain. And now, if the attacker figures it out, they can take out that domain and host OpenID config metadata document and the public keys that are required to validate the signature of the token. So attacker has a public key private key pair, hosts the public key on the attacker controlled domain now, and now sends a signed assertion to Entra ID. Again, we saw the client credential flow, and where you have to just see is the client assertion. In the client assertion, you just have to put in a JWT token that is signed by the private key. Now when Entra gets this request, Entra ID, it pulls up its configuration and then reaches out to the trusted issuer. Here in this case, it's cloud.secure-sts.com, and fetches the well-known config endpoint. And that's again a JSON document, and it reaches out to the JWKS URI, fetches the public keys. Now it has the public keys to validate the signature. So the token is signed by the attacker's private key, and it's being validated by the attacker-owned public keys. Now all of a sudden, the Entra will be able to validate the signature and issue a token back to the attacker. So once the attacker has the access tokens, they can impersonate that identity, do pretty much what that identity is capable of. So here in this case, in our fictitious setup, we have the attacker has the access token. They can impersonate the service connection and deploy resources to the Kubernetes or the resource group, whatever that it has access to. So in a nutshell, take over the domain, host the OpenID config, metadata document, and other JWKS keys that are required, and eventually send a signed assertion, and that yields in an access token to impersonate. And let's look at a quick demo here. This is a custom domain takeover, And before I do a video of the demo, I'd like to give a quick shout out to our Düsseldorf team. Düsseldorf is, by the way, an open source, Microsoft's open source tool for to capture out-of-band interactions. It's very similar to Burp Collaborator. By the way, it's open source. You can search at aka.ms/Düsseldorf. And it has some bunch of additional features like given a specific regex pattern, it's going to return a certain response back. So there are some cool features that it has, and while I was doing research on Federated Credentials, I happened to use this amazing tool, and it really helped me. So here in this case, I was configuring cloud. I took over cloud.securests.com and then hosted the OpenID config and the public keys that are used to validate the signature as rules. And then, as you can see here, this is the OpenID config, well-known OpenID config, and then the JWKs are the public keys that are used to validate. Now we'll do a quick video. It's going to be really quick, so this is the token exchange tool that I vibe coded specifically for this conference, and then using the configuration, it will sign a signed assertion and then send a token, send a client credential flow request to Entra ID and retrieves an access token back. So here in this case, it's currently running now. I'll just play the video. So it's signed an assertion and got an access token, and you can also see the out-of-band requests that we received from Entra ID to fetch the well-known OpenID config and the JWK URI, and eventually it uses that token to access the resources in the resource group. So in a nutshell, we use Düsseldorf to capture the interactions, put in the well-known config and JWKs or public keys, and then requested access tokens using token exchange, and we got the tokens back and used them to literally move into Azure environment there. So I have a few screenshots here as well, like that quickly show you the signed assertion with the private key. So I'm not displaying the signature here, so that's why you don't see the signature. It's just a decoded assertion, but you can see the issuer is cloud.secure-sts.com, and then got the out-of-band request from Entra, and eventually got the JOT token back. And I was using the federated token with the Azure CLI to list out all the resources. So here's how you can list out all the resources using the Azure CLI as well. So we can either use the APIs, or we can also use the Azure CLI with the federated token. So it's going to do the same thing. So that's about dangling issuers and app registrations. We also have another scenario here where we'll look at dangling issuers and user-assigned managed identities. So as I said, like there are two ways: one, app registrations; two, user-assigned managed identities. In the user-assigned managed identity setup, so we can see, there is a user-assigned managed identity that is configured with a static website that's hosted on Azure storage. It's configured as the issuer. Again, like if developer forgets or deletes that resource, now the configuration is still there, but they cannot. Now the developer will be able to, or the attacker will be able to take over that domain and eventually obtain tokens. We'll see. It's a pretty same flow. Here in this case, the attacker is going to take over the storage account and then use the attacker controlled STS, host the well-known config, JWKs, URIs, or public keys, send the signed assertion. It's going to be the same, like get the JWKs public keys, and eventually gets the access tokens back. And attacker uses the access tokens to laterally move to Azure resources. And I wanted to quickly talk about the research that I was doing while I was working on the Federated Credentials. I was setting up the Azure storage account, which is hosting a static website, and I had to enable static hosting, and that's when it gave an endpoint, say cloud-secure-sts.z13.web.co.windows.net. Here in this case, I was curious on the suffix .z13. I was looking up online and I couldn't find any public documentation on what it meant. And then I did some LLM thing, and then I asked Copilot to create a a script that can create storage accounts in all regions, and then I enabled static website hosting. That way, I was able to derive that, okay, here are the list of URLs, here are the regions it hosted, and then I was able to map, okay, the certain suffixes map to certain regions, and here is how it looks like. So this is something that I discovered. There was no public documentation, so while I was preparing for this presentation, I thought I'll share this all with you. But anyhow, so again, going back to our dangling issuers in Azure Storage, it is the same thing, like host the OIDC metadata files in blobs, and then use the, this is the OIDC metadata OpenID config, then the JWKS URI, and now I'm going to use the same token exchange tool with a different configuration to obtain access tokens. So here in this case, I won't see the out-of-band interactions because I don't, that's hosted by Azure, so it's just going to pull the required files in the background and then obtain keys. So the demo is pretty quick. So it now, in this case, it sent a signed assertion, obtained access tokens, and used the access token to dump a key vault. So here's a quick snippet of the key vault that I was able to dump using the access token. So to quickly summarize, what did we see here? So we saw two different domain takeovers. One, using a custom subdomain, custom domain like cloud.securest.com, and then second, using a cloud service subdomain like an Azure Storage that is hosting static website, and host OIDC metadata files, sign assertion that leads to an identity impersonation. So let's take a moment to see what are some of the risks of this dangling issuers, and why do enterprises really have to worry about this issue? Because it's typically a hidden backdoor for app registrations or any identity, because attackers can now take over and then forge tokens, and eventually that's impersonate an issuer, and eventually they can also impersonate identities of that, and that, depending upon the identity configurations, they can escalate privileges, laterally move to Azure resources, and even the cross-cloud, because of, if they've configured with cross-cloud configurations, they can laterally move into the other cloud environments as well. So that's a real risk that we have. And lastly, it's a very stealthy attack, because there was literally, it is impersonating an issuer, and there's no way, it's very hard for our defenders or blue teamers to find out the attack that's really happening, because it's all happening on the identity front, and there's no trace really that's left. What can we do about this problem then? So we have some ways to detect or at least discover the issuers that are in federated credentials. So for app registrations, there is an API that's supported to list all the federated credentials, but it needs some permissions like application.read.all or application.readdate.all. And for user assigned managed entities, similarly, it has another API that can list all the federated credentials. And what you can do is you can ask any LLM to generate a script, list out all the federated credentials, and then look for any of them that are dangling. So that could be another avenue for discovering them. So are there any prevention strategies? Yes, fortunately we have some, but it's only limited. Like in this case, we have an Azure policy that can prevent adding any random dangling issuer. So here in this case, I've configured a policy, and then I've configured an issuer URL, and that's not allowed listed, and then eventually it didn't allow. So there are some preventions, but this is only applied on the user assigned managed entities and not on the app registrations. So for app registrations, you might have to rely more on conditional access policies. So that's something that we can explore. So what are some of the key mitigation strategies? So again, the mitigation strategies that we can follow here are limit issuers to only the trusted ones. So don't add any arbitrary URLs or arbitrary issuers to the federated credentials. And always verify the domain ownership. Make sure that if you have any trusted domains configured, make sure that they are properly owned and properly registered. And also have a continuous auditing and cleanup monitoring on your federated credentials. and make sure that we are not leaving any of them dangling. Or if you notice some anomalies, try and mitigate them. And lastly, also enforce some allow lists or policies on the issuers that are in federated credentials. So those are some of the key mitigation strategies that I can propose here. And lastly, there are some additional future research opportunities. So I've been looking into the federated credentials in Entra ID space, but there are definitely opportunities. I'm sure there's going to be similar cases in AWS and GCP. I've not looked into that space, so that's another one. And then there could be some misconfigurations in flexible federated credentials. That's a new thing that's coming up, and also some identity takeovers, or workload identity takeovers in Dangling repositories and stuff like that. So that could be another interesting area that we can poke at. With that, I'd like to quickly call out some related research. There was a talk by Dirk Jan on CFCon on the same lines. I wanted to quickly give a shout out to Dirk. He's been a fantastic Entra ID contributor and collaborator there. And I also wanted to give a shout out to one of our red teamers, Chris. He's also in the hall today. He presented at BSAT Seattle on literally using federated credentials to literally move and dumping keywords. So yeah, quick shout out to Chris. And here are some of the references, and that's pretty much it I have for you all today. Thanks everyone for joining. Thank you so much.